Hi everyone, I'm Xiaoqi. Today I'm going to introduce an incredibly significant, and I think it's a game-changing product to you. It's also a product that our Robosn is about to launch very soon, and I truly believe it's a massive milestone product. Internally we call it FlyCore. Right here we can see this specific board, which is the most important board. This is the central core board of FlyCore. This is its main flight controller and the primary IMU, and over here you can see that the RTK module is actually fully integrated as well. This forms the core of the FlyCore. Of course, there's also another component here. You can also mount a LiDAR on top. When these are stacked together, they form a complete core, which is the core of the FlyCore. Here is a smart battery that powers the unit. This is a normal drone frame, which also contains an integrated ESC, the controller and the video and data transmission link. We are about to take on a significant challenge. Starting from this very moment, we want to build a professional, industry-grade drone just like this one within 1 month. We all know that actually DIYing a drone isn't that difficult, but if you want to build one with industry-level fundamentals, like being able to fly in places without GPS or having a smart battery, that's a different story. Meanwhile, there are also aspects such as the ISP tuning of the camera, as well as its stability and robustness. Last year, we released the industry's B01 Crystal product. In fact, from the start of development, it actually took us 4 years to develop the B01 Crystal. With a device like this, I think we can take on a challenge. I believe that within a month, we can build a model that has a smart battery, can fly even without GPS positioning, and is also capable of mapping, localization, and obstacle avoidance. Well, for a highly sophisticated industrial-grade drone like this one, the very first thing we absolutely need to do is complete its comprehensive structural design phase and then finish some extremely meticulous parameter tuning before we can even consider it operational. We will carry out a comprehensive series of rigorous flight tests for it, as well as an extensive long-duration endurance evaluation, after completing the full sequence of developmental and safety procedures. We will meticulously document every single observation and data point in detail. Actually, I just raised a question. Why is it called FlyCore? So I'll give you an explanation from 3 levels why is FlyCore. We should explain clearly from the comprehensive perspectives of underlying hardware architecture, software architecture, and the specific interface layer, why it is called the FlyCore. First, let's take a moment to talk about its internal hardware architecture. In fact, when looking at it specifically from a hardware architecture perspective, its most typical and impressive feature is that it has successfully achieved a remarkably high level of system integration. To begin with, let's look at the first feature. And the second feature is that it actually has 3 separate high-performance computer processing units. So, what exactly are these 3? The first one is what is commonly referred to as the mapping and localization specifically designed onboard computer. This entire process is successfully accomplished by the high-performance Intel Ultra chip. Furthermore, there is also a dedicated onboard computer system responsible for advanced recognition and strategic planning. In fact, within this specific section here, we have also seamlessly integrated an additional RK3588 chip to enhance the overall processing capabilities. This is actually the dual onboard system at the brain level, which we also refer to as the left brain and right brain. Just like in humans, I mentioned earlier that it has 3 onboard systems, and this is actually one of its onboard systems as well. This is a flight control system, so we call it the basic flight control onboard computer, and it is implemented using a microcontroller. So just write this position. The microcontroller is used because it requires real-time performance. That's why a microcontroller is used to build it. Also, inside, it has an MU gas sensor, as well as an integrated RTK sensor. This effectively explains, at the hardware level, why it's called FlyCore. First, it has a remarkably high level of hardware integration. Second, we've integrated the left brain, right brain, and the cerebellum, these 3 central control systems, directly into this specific type of unified architecture. So, how should we understand this FlyCore at the software level? Actually, on the software side, we have built a mapping and localization algorithm into the Intel Ultra chip. At the same time, it can also work with our Prometheus algorithm for path planning and autonomous navigation. At the same time, we can also integrate recognition algorithms like Spire CV into the system in the form of software packages. So why do we call it FlyCore at the software level? To sum it up, it's basically OODA. The first component is the mapping and localization unit. The second element is the recognition and perception unit. The third part is the planning unit. The fourth section is the flight control unit. All of these systems have been distinguished accordingly. At the same time, we have also created some interfaces. We introduced what FlyCore is from two different perspectives. Finally, before we actually get hands-on, we think it's necessary to give everyone an overview of all the interfaces that FlyCore provides. Of course, the parameters for these interfaces should ultimately be based on the descriptions in the wiki documentation. In addition to the hardware architecture, software architecture, and interface explanations we mentioned earlier, we have also made many detailed optimizations. The first one is electromagnetic compatibility, or EMC. The second one is that we have also added the vibration damping for the flight controller. We've also done a significant amount of work on ISP debugging. In fact, our core goal is to make it extremely efficient and easy for everyone to build drones using our FlyCore system. Previously, when we developed our own internal system, it actually took us 4 long years to complete. So I hope everyone can use this tool just like the slogan I mentioned today. You can complete the development of a smart drone in just 1 month. Next, we're going to get hands-on. We'll 3D print the structural design, and then there are some sensor or calibration tasks to do. In addition to those steps, there are also some critical PID parameter adjustments that need to be fine-tuned for optimal stability. In the end, we will open our specialized ground station software directly on this remote controller, allowing us to maintain full manual control of the aircraft, even when flying in challenging areas without any GPS signal available. Next, we'll go on to implement obstacle avoidance, autonomous flight, and a series of other functions. Okay, let's get started.